apologies. On the road now. Okay. Okay. Hi everyone. Today I'm going to be doing my presentation on what is a supernova. We're going to be going through what they are, their history, and current research. Okay. Now, so what is a supernova? Supernovae are basically massive explosions of a star. The energy of the explosion releases more energy than our sun will release in its entire lifetime. They occur approximately every 50 years in galaxies the size of our own Milky Way. And most of the heavy elements found in the universe are actually produced from them. And this picture we have here is actually a combination of two images. This is actually a remnant of a supernova. The blue shows X-ray light, and the red actually shows what's visible light. Okay. So supernovae are both creative and destructive forces in the universe. You only think they're going to be destructive, but they're actually playing an important role in the universe into bringing about new stars and even life. So, as I said before, they can create new stars, and how that works is the energy of the supernova. It interacts with nearby gases, it compresses the gases together, and that can trigger a fusion reaction. And the supernova can also fuse elements heavier than iron. And they provide the building blocks of life. So without them, we wouldn't be here today. And they also emit cosmic rays, which mutate DNA. And that's basically what you can see here. You can see what X-rays do to DNA, and also some heavy ion radiation. And it mutates DNA, which can accelerate evolution as well. So, types of supernovae. There are two types. Type 1 are basically white dwarf stars, which suck matter from a nearby star. And they become so large that it reaches a critical mass and it just collapses and a supernova takes place. They are easily identified by a lack of hydrogen signature in the light spectra. And type 2, they occur, well, this is the type that most people think of when they think of supernovae. They occur when a large star runs out of fuel at the end of its life, and basically it collapses into its own, due to its own gravitational forces. It causes an implosion, and then it basically hits the solid core inside, and then it ricochets out and becomes a supernova. And you can see in this picture too, the type 1 is the first one there. You can see the white dwarf sucking matter from the companion star, and the second type there, type 2, is what happens at the end of a large star's life. Okay, the Crab Nebula, which is what this picture shows right here. Well, basically, before the 17th century, there were only 7 recorded supernovae. One of the most famous events is what's known today as the Crab Nebula, which is that there. It was recorded in the year 1054 by the Koreans, the Chinese, and also likely by the Southwestern American Indians. There was evidence from this because it was documented in cave paintings. Crab Nebula was visible for several weeks, and it was very bright. In fact, it was so bright that it was visible during the day. There's one transition that works. Okay, modern supernova. Okay, so a famous supernova occurred on the 24th of February 1987, the year I was born, and named SN 1987A. And you might be able to tell from the name, The naming convention for supernovae is the year that they're observed. That's comes to us in the name there. Okay, this supernova was observed in Chile by Canadian astronomer Ian K. Shelton. It shone at a magnitude of 4.5 and climaxed to 2.9, and it was therefore visible to the naked eye. Now, the supernova SN 2008D was the first supernova to actually be observed in the process of exploding. It was actually by chance. They just happened to glance upon it and saw there was a massive burst of X-rays, and they caught it. It was very lucky. Yes, it caused a burst of X-rays that lasted for 5 minutes. And that's what we want to. Now, could sound be the trigger? One theory that's going about right now is that audible sound waves are the final trigger in the explosion. So basically, this sound wave, it ranges from 200 to 400 hertz, which is middle C to the musically inclined. Basically, the new simulation that they're running, it turns the sound into a colossal speaker. The oscillations have enough power to drive the final explosion. But there's a lot of skeptics about this, and ongoing research is underway. So, you can either believe it or not. Supernova doom. In 2014, NASA gave a $500,000 award to the University of Kansas for their assessment on how devastating a nearby supernova would be. And as you can guess, it would be pretty devastating. Straight away, pretty much the ozone layer would be stripped away, leaving us vulnerable to ultraviolet radiation. Also, the Earth would be showered by cosmic radiation for thousands of years, which would cause cancer, and cause cancer and climate change, and obviously, pretty much life as we know it would cease to exist at that point. And that's my references. And are there any questions? Yes.
You said that the current value was so bright that you could see it during the day. Does that mean that it actually had an impact for, on the climate of Earth, or did it destroy some stuff on Earth? Or do we
As
don't
far as I know, it didn't impact the actual climate, but one thing I can think of is that perhaps the local wildlife might have been a bit confused, like the birds might have thought it was still day, or even, I don't think it would actually affect the weather or anything like that. It's just an extra bit of light. It's not like it was heating up the Earth.
You said that the X-rays were visible for about 5 minutes in that supernova. How long does it actually take for an actual supernova to occur?
That is basically,
that's the whole thing?
That's the bit. It's a very quick event.
Okay.
So it's just a big burst of X-rays and gamma rays and cosmic rays, and then basically it just kind of expands into what's known as a remnant. It'll keep emitting cosmic radiation, but the main explosion is very quick. Yes?
Are there any other ways to find them apart from, like you said, 2008 or something? We just by chance saw them. Are there any ways of detecting them?
Well, yes, actually, in 2012, we released a satellite into orbit, which is actually a telescope, which is actually able to focus X-rays. And this has been used to get a better look into them.
So it just searches for X-rays and...
Yes.
Okay.
That's what it specializes in. Yes.
When you said that they thought that sound waves could be like the final thing that caused the explosion, do you know if they know where the sound waves are coming from that caused the supernova?
It's kind of like... Do you know what resonance is?
Yeah.
Yeah, it's basically an object pretty much has its own frequency that if it gets force applied to it, or if it's undergoing any kind of change, or it'll start to vibrate at that frequency. And because the sun is so large, it's going to be a massive oscillation, and that's what they're thinking is the driving force between the final explosion.
So the sound waves come from the
sun itself. It's
from the resonance of the
that's
of
right.
the actual supernova. Oh,
That's right.
Okay, good.
Thank you.
Next up.